We're getting ready to tackle polynomials here, so I wanted to make sure we had an understanding of these three rules that will most definitely come up in class and on the homework. And the three rules are the product rule, the quotient rule, and the power rule here. So I've got some example problems for each of these that I figured we could go through today. So let's take a look at the product rule. Product means the solution to a multiplication problem. So when we talk about the product rule, we're talking about multiplication. You will utilize the product rule when you're multiplying terms together. And the product rule states that when you're multiplying terms that have the exact same base, which these all do, these all have a base of y, when you're multiplying things of the same base, you keep the base just the way it is, and you add the exponents from each term. Okay, so looking at problem 1 here, we see the base is y. So we'll keep y. And those exponents, we're going to add those up. That's 4 plus 6 plus, and you might think right here that there's no exponent, but if there's a y there, if there's a variable, there's definitely an exponent. It's understood to be a 1. So we know that exponent is a 1. And that'll give us a final answer of y to the 4 plus 6 plus 1. That is 11. And that would be our answer for problem number 1. Let's take a look at problem number 2 here. On problem number 2, we've got some leading coefficients here, some numbers in the front of our variables. Well, we know how to take care of that. We know how to do negative 3 multiplied by 6. That's just negative 3 times 6. And then, of course, following the product rule, if we have same exact bases, we can multiply them together. We just keep the base the same, and we add these exponents for a final answer of negative 3 times 6, that's negative 18. And we'll have x to the 7 plus 5, that's 12. And we're finished with problem number 2. Problem number 3 is pretty similar to problem number 2, right? We've got leading coefficients, but we've got two different variables. But that doesn't change much here. Start off the same. We can do 3 times negative 9. Okay. And then we can only multiply terms of like bases. So we can multiply the x's with the x's over here, keep the base the same, and we add the exponents. That's the product rule. Okay. We can multiply the y's with the y's, keep the base the same, and we add those exponents. Right, it's understood there's a 1 here. And this final answer would be 3 times negative 9, that's negative 27. X to the 5 plus 2 is 7. And y to the 1 plus 3, that's 4. Oops. Okay, so examples of the product rule there. The main takeaways for the product rule are leading coefficients, you just multiply together like normal. And for the variables, you keep the base the same, and you add the exponents. Let's take a look at the quotient rule. For the quotient rule, if we're talking about quotients, that means we're talking about division. So you'll use the quotient rule when you're dividing terms. And we can see we've got some division going on here. We have x to the 6th divided by x. The quotient rule states that when you're dividing terms that have the exact same base, you subtract their exponents. So in this case, our base is x, and we're going to subtract the exponents. That'll give us an answer of x to the 6 minus 1, which is x to the 5th. Let's take a look at problem number 2. Very similar, but we've got multiple variables and we've got some leading coefficients here. For the leading coefficients, we just treat it like a fraction and reduce it like normal. So if we're looking at 4 over 28, we can look at 4 and 28 and see that the GCF is 4, right? 4 goes into both of those. So we'll reduce both of these by 4. 4 goes into 4 once. 4 goes into 28 7 times. So far we have a 1 on top and a 7 on the bottom. Now we can move on to our variable terms. Here we have h to the 4th over h to the 4th. Those are like bases, so we can subtract those exponents. H to the 4 minus 4. And then, let's see here, we've got g to the 5th over g. Those are like bases, so we'll have g to the 5 minus 1. For a final answer of 1/7. Now h to the 4 minus 4, 4 minus 4 is 0, and anything to the 0 power is 1, so that's going to go away. But then we'll have g to the 5 minus 1, that's 4. So we end up with an answer of 1 g to the 4th over 7. And that is the quotient rule. Finally, we'll take a look at the power rule here. The power rule is whenever we're dealing with exponents, so we're raising a term to another power. Like we are here, we've got our term and we're raising it directly to another power. What we do here is we keep the base just the way it is, and we multiply the exponents. So this would be z to the 2 times 6, which is 12. And last one here, we've got two different terms. We can't reduce these terms because they have different bases. So all we can do is apply the power rule here. We need to apply this exponent to both terms. So we will have f to the 9 raised to the 5th power over g to the 5th raised to the 5th power. And again, we keep the bases just the way they are, and we multiply the exponents. On the bottom here, it'll be 5 times 5. For a final answer of f to the 45th over g to the 25th. And that is it. So that's a look at those 3 rules, a quick crash course there. They'll definitely come up in the homework problems, so make sure you have an understanding of those moving forward.